Welcome to IT Trendsetters by SynerComm. Today's discussion is with Bill from SynerComm and David from EnTrust. And the topic we're going to be talking about today is code signing and secure development. So David, appreciate your time today. Before we get started, let's start with Bill. Bill, I think we've crossed paths a few times, but we've never actually got together. This is the first time doing this type of format. So can you tell me a little bit about your role at SynerComm and a little bit about yourself?
Sure. Well, Chris, my role at SynerComm is a software architect. Day to day, I am building software. I am learning and following best practices, but I also consult with organizations, ones who are new to building software or have been building it for a while. They want to know, how do we do this well? How do we do this securely? And I've been doing that for about 5 years with SynerComm, but professionally being closer to 10 years now.
So tell me one thing that you found that you like to do during COVID.
Oh man, hiking.
Hiking.
Uh, it's something I didn't do enough of before, but boy, once things start locking down and start to enjoy nature, hiking's been great.
Nice. Well, David, this is the first time we've ever met. Could you tell the audience here a little bit about yourself and some background on EnTrust?
Sure. I'm the VP of Professional Services over at EnTrust and had worked in the security industry for quite a while, including some stints at RSA Security. You may have heard of them for 10 years. And then, I've been over here at NCipher/EnTrust now for 3 years. And got to work with a variety of different security topics and got to live through the RSA breach that happened years ago. And, in my role right now, I spend a lot of time talking to customers and, talking specifically about how they can better secure their environments, whether they're building IoT devices or if they're multinational banks. It's a pretty wide playing field, which makes it a lot of fun.
And where are we talking to you from? Where are you located?
I am in beautiful Galveston, Texas.
Nice. Is it, what's the temperature there today?
Well, this morning it was 62. At lunchtime it was 42. So we're going to get that Arctic blast that everybody's so excited about.
Oh yeah,
Bill's
I'm
like,
calling it.
you don't know what an Arctic blast is where Bill is from.
Yeah.
But yeah, I'm talking to you guys here from San Diego. I still have shorts on, but I had to put socks on today to keep my feet warm.
Ooh.
All right, so
uh,
let's get started. So let's start at the high level here, and this is going to get really nerdy between you two, and I'm going to try to ground it as best as possible for us, kind of not so technical people. But tell me, what is code signing, and what is it used for?
Sure. So code signing itself is really the process of taking a piece of code, whether that's, let's say, either like a Windows executable, or it could be firmware that's running an IoT device, or any piece of code, and applying a cryptographic signature to it. So essentially what you're doing is you're taking a asymmetric key and you're taking a hash or a fingerprint of the code, and you're signing that fingerprint and saying, by doing that, you're attesting that, yes, I am the holder of this key and I say that this code is from me, is essentially what you're doing. Now, it's tied to a public key infrastructure behind it so that when you get that software, if somebody signed it and it says, hey, this is EnTrust signing this, you know who EnTrust is and you know to trust them, right? So I won't go into the whole, what is a PKI, because we only have, a couple of hours. But yeah, the idea behind it really is having trust behind the code that you are developing. And, we're seeing code signing being used a lot more than we'd seen in the past for a couple of reasons. Number one is a lot of enterprises now are not allowing their company-owned laptops or servers to run code that isn't signed. For obvious reasons, hackers, may not want to give you a signed piece of code because they don't have the right certificate to sign it with. So that's a great way to kind of block and filter out malware, is requiring code to be signed to run it in your environment. And of course, once companies start doing that, all of the software vendors that are supplying them with software also have to have signed their code. So we had a number of customers we work with that initially hadn't provided signed updates. Their updates were available on their tech support site, for example, right? So yeah, we're pretty sure that if we go to your tech support site and get it, it's from you. But now their laptop doesn't care. It's not going to run it. It's not going to run the update unless you have that signature attached to the code. So that's really kind of what it's used for, as well as really making sure that whatever it is you're running is genuine.
Now, Dave, I think you explained it pretty well about how this establishes trust between the end user, the end environment, and the source code itself, or the deployed code, I should say. But this whole series of trust, what are some of the ways that it can go wrong? How can code signing go wrong?
Well, there's a few ways, right? So while the process seems like, hey, that'd be a great idea, I just sign this, people know it's for me. What could go wrong? What can go wrong is if somebody impersonates you. So let's say someone's able to gain access to the signing key, right? And now I can take that signing key and I can create a piece of malware. I can use your signing key to sign that malware, and I can distribute it. And people will look at it and go, okay, it looks like an update from, EnTrust. It's digitally signed. It's digitally signed by them. So I trust it. Unfortunately, that, again, if that key is compromised, then the code that's being signed isn't really the code that you want signed and you want with your name on it. And to kind of combat that, there's a lot of processes that can kind of go around protecting that key, or protecting the process of how that key is used. So that's usually when we're talking to customers, that's their biggest concern, is making sure that someone isn't signing something that shouldn't be signed, because that's their name, it's their brand, it's their trust.
So
So
I just briefly there, I saw a new word in this that I've never heard: cryptographic hash.
yes,
That is
so
definitely a new one.
yeah, it's think of it like a fingerprint, right? So it's unique to every piece of code. There's cryptography behind it to calculate that, what that string of digits is, but essentially it acts as a fingerprint, right? So I don't have to sign, a piece of code that might be, hundreds of meg large. I just have to get a fingerprint of what that code is, and I can sign that fingerprint, which is much, much smaller. Maybe a question for you, Bill. In your experience, can you think of any examples where code signing has gone wrong?
Yeah, you know what? First place I think of is the news for that, Dave. Now, it probably doesn't make mainstream news all the time, but there are quite a few examples that people have seen headlines for. So I was thinking, I tell you what, I'll give you an example of a couple prominent ones, and let's see if we can't identify them together just based on the details.
Yep.
Now, these sorts of things, every time I see them, they're always somebody getting into the build process in order to compromise the code signing itself. So there are really two ways to do that. You're either on the outside breaking in, for instance, some type of remote attacker, or even from the inside out in some cases. So how about this? SQL injection. So you have some kind of public facing application hosted on the internet. SQL injection leads to a compromised network. Lateral movement takes the attacker to the build process, and there the build process is compromised and some malicious code makes it out signed. Any idea who that might be?
Well, there's probably a couple that come to mind. I think, obviously there's a pretty popular one that's out there now that I'm not sure if it was compromised through SQL injection, but very similar, moving laterally into the build process to get malware signed and distributed. And obviously that's SolarWinds. But I don't know if that's the one you were talking about.
Absolutely. That one wasn't SQL injection, but it follows
Yeah.
basically the same format.
Yep.
I've read some of the details about that one, and it's crazy the patience involved. Once you get that outside access,
Nope.
once you've compromised a single system, moving around, patiently waiting months, testing things with empty classes in the code, seeing if you can get away with signing it.
Yep.
Sophisticated stuff.
Oh yeah, I mean, it was clearly the work of a very patient, well-funded, and very well schooled attacker who not only understood, the methods of attack, but also the methods of defense. And I think that was one thing about the hack where they really understood how people would be looking for the intrusion, so that they did a really good job of covering it up, hiding it, obfuscating it. And obviously that makes it a huge challenge for companies to try and defend against something like that, because how do you defend against the unknown, or how do you fight something that's already designed with your defenses in mind, right? This isn't the days of AV, signature-based AV, where we've seen this hack before and we just spot it.
Yeah. Hey Dave, have you ever used TeamViewer?
Yes, actually I have.
That's I
It's been a
read
little
about an
while.
interesting one. They so there's nothing wrong with TeamViewer itself in this instance,
Yep.
but there is a software developer that was running it and using it as a service for remote desktop.
Yep.
Through some stolen credentials, somebody compromised through TeamViewer that developer's machine. You get your privileged machine there, you do some lateral movement, maybe install some keylogging malware, and boom, that made a headline for CCleaner.
Yep.
Which that was a popular one for cleaning up Windows desktop environments.
Yep. And I think, one of the challenges that a lot of times we have in talking with folks who are in sort of the development community, or, are responsible for the DevOps in their company is, developers almost inherently believe that they know what they're doing and nobody's going to get at them, right? Because they're smart technical people, right? And they're not going to do anything dumb like have guessable passwords or, anything like that. Right? Never, right? So, a lot of times there's sort of a resistance to locking down those environments, because developers like to be able to do whatever they need to do technically, and not have to worry about it. But when you get breaches like this, it sort of underscores the importance of keeping that development environment secure.
Absolutely. And speaking of these smart engineers and such, it seems like no matter what, it's only a matter of time before the human element comes into play.
Yep.
Even the best systems can't do much when a phishing campaign is successful and installs malware on some engineer's system.
Yep.
And
Yeah, and I think, as we kind of link that back to the code signing world, we see a lot of folks who are doing code signing, but the keys are on a developer laptop. Like, oh, he's the build lead, he's got the keys on his laptop and he signs it. Well, same thing. If he gets phished, or somebody in his facility gets phished and they're able to move laterally into his laptop, then poof, they can sign it, because there's no real control over it. And I think that's one of the things that we talk about with customers a lot is you can have a dev environment where that's loosey goosey, that's fine. Have a development key to sign the stuff with, and trust that key only in the development environment. So that way you're not worried about, great, development key gets compromised, I don't really care because nobody's going to trust it outside of my little dev environment. And I'm also not, I'm only using it to trust to execute code that I just built myself, as opposed to something that's publicly trusted that I'm shipping out to, 30,000 customers around the world.
makes sense. Well, Dave, there seems to be a common element in all this, and that once someone's compromised a system, they inevitably get access to the supply chain. Now, I mean, it seems like for a lot of systems, compromise will happen in a matter of time. It's not really if, it's when. People try to stay proactive, but What can they do? I mean, what can they do to improve the security of that process? How do they protect their code signing?
Yeah, so I think there's a couple of threads there, right? So yeah, if you look at some of those breaches that are very detailed and involved, uh, there's all kinds of ways that the attackers look to sort of get in the door. And to your point, you have to assume they're going to get in, right? There's uh, way too many examples of places where people thought they were secure. I've got great perimeter security. I analyze all my logs looking for stuff that's happening, and that's all well and good, and you need that too. Um, but if you're looking to secure sort of the code signing process, I guess the real key pieces there are obviously securing that key is paramount. And a lot of the companies that we're talking to now are looking to start to do that centrally, right? They're looking at as a security resource, as a security thing, and not a development thing, right? So they want the security team to hold that, protect that, but enable the development team to use it as necessary. So, and that's really sort of the second piece, which is how do I have appropriate workflow, appropriate access control, appropriate identity, so that if I do want to sign something at that moment, I know that it makes sense to be signing something at that moment. Like, yes, we did plan to get a customer build out or a hot fix out, so I would expect now to sign that hot fix. Um, know who's requesting it. Know that somebody may have to approve that and say, yep, as the security manager, I'm gonna verify that this is the right thing and say yes before we go ahead and sign it, so that sometimes the automated processes that attackers might take advantage of might work in a dev environment. The minute you start to go into something that's externally trusted, you can kind of step back and say, like, we want some human eyes on this thing that's going out the door, because hopefully we're not building stuff that's going out the door every couple of hours, right? We might be doing that internally, but not externally.
It's funny. While the human element can weaken some processes, it seems like it strengthens others.
Yeah. Well, again, it's just finding finding someone to take an objective look at what's occurring, um, because again, attackers are pretty good at fooling systems that are known and well defined. Sometimes it's a little tougher to get some of the stuff past a human. Oddly enough, it seems like the reverse of what we've been teaching for years, that computers are smarter, but sometimes it is just that human look that says, hey, wait, that doesn't seem right. So I think, I guess, it might be good to kind of take a little bit of a step back. And we were talking about the build process. Um, if you can, Bill, kind of maybe talk a little bit about sort of what's the bigger picture of the build process, and how you see code signing fitting into that.
Sure. So I can offer the developer perspective here. And the bigger picture for me is software development lifecycle. That is from beginning to the end, and it's cyclical, of course, in that you can start out with code and eventually it is deployed and running, but then you make updates and you keep it going. So in that cycle, code signing to me falls in the deployment phase. When you're ready to put it to test or production, you need code signing to ensure integrity and trust.
Well, how does that challenge? So being in the development environment, does that introduce any challenges to you? I mean, because obviously we can always talk about all these great and wonderful security measures, but if they get in the way of doing your job, or what you perceive to be as or perceived to be difficult, sometimes they're not maybe widely adopted. So have you seen any examples of that, or any other areas where you think that this might the SDLC might be challenged?
Yeah. So the SDLC, the more you add to it, and code signing is adding another step or series of steps to your SDLC, it's increased complexity. Sometimes development teams are strained on resources or time or both. And what we see here is, well, the complexity, it causes weaknesses. So like, first of all, the complexity of code signing, it generally increases your attack surface. Maybe that's a particular machine, appliance, or installed solution. And maybe you didn't have an automated build process before, but introducing code signing, you did. In any case, whether human or automated, it tends to just add more steps to the process.
Yep.
Some companies treat it as a check mark. Hey, yay, we do this. Maybe they don't do it well. And others take it very seriously. They value their users, they value data, they value the integrity of the whole process. But in 2021, things, even if your build process isn't getting more complicated, a lot of times your deployment one is. From cloud versus on-prem to test production to, gosh, I mean, even the type of environment. Maybe you're not deploying to a VM like you used to, and maybe you're deploying to some kind of containerized cluster. Maybe it's an app store running on a thick client or a mobile phone. Just things have changed and become very, very complicated. That's a lot of challenge for development teams to keep up with it.
Yep. And I think also, to your earlier point about increased attack surface, as things get more complicated, there's more moving parts. That's more, potential parts that could be exploited or compromised along the way.
Absolutely. And Dave, we've talked about some of the things that can go wrong, the complexity that we see today. And in 2021, I mean, from your perspective, what sorts of steps should people be taking? What should they look to add to their process this year to strengthen it or simplify it, to get it under control?
Yeah, so I think, certainly within the SDLC, there maybe hasn't been traditionally the amount of security attention that there's been to a lot of other areas and companies, right? So if you think about, network and perimeter defense and threat analysis and, crowdsourcing of threat data, and, a lot of companies are doing that kind of stuff, but, within the software development lifecycle itself, maybe not as much attention has been paid to security. So I think, certainly recent breaches will kind of encourage folks to think a little bit more about looking at the SDLC as a whole. And I think, within that, you look to protect the pieces, right? Look to protect the build process, look to protect the automation, look to protect your source repositories, and of course, look to protect your code signing, right? Because it doesn't do you any good to, you're protecting all that other stuff, and then someone just takes their own malware, signs it with your keys, and then poof, they can distribute that malware with your name on it. So I think that, a big part of it is trying to view the whole SDLC and how can I secure those individual parts better. Knowing that nothing is, ever 100% completely secure from a really determined, well-resourced attacker, but certainly you want to take due care of all of the steps within your process. Try to do the right thing, protect the stuff that is the most valuable, and ideally make that just sort of part of the normal process of building products within your own company, right? Is security is part of it, just like security is part of everyday life now, and it wasn't 20 years ago. But now it's just it's kind of baked in and built into companies, and they're very mindful of it. I think SDLC is one area where we can really kind of extend that. And I don't know if you had any thoughts about that. Again, being a developer yourself.
Yeah, I think the biggest impact on that for me is securing my SDLC was really, it started with picking a framework. In the development world, there seems to be a framework for everything, whether you're doing a client or a server application, but this is yet another one, but it doesn't have as much to do with the code itself. So the one I picked out, and I've looked at quite a few, but my favorite so far is BSIM, Building Security and Maturity Model. And really, it's a collection of best practices. I've found that really helpful for my team and also the teams I've worked with at other organizations to suggest that they adopt a framework like BSIM and use it to track what they do now and what they want to do next and what other people are doing. It's really a great way to figure out where you're at. You can't improve on something that you're not aware of. And then roadmap where you want to go next. Beyond that, how do you know when it comes to code signing, certificates and such, when something's gone wrong with yours? How do you keep up with certificates? Dave, how do you know when your certificate's been compromised or misused?
Yeah, unfortunately, a lot of times you find out because somebody calls you and says,
Oh,
"Hey, I'm over at XYZ company, and we're trying to figure out we've got a malware infestation, and we're trying to figure out why this executable went out with your signature on it." Obviously, that's not a phone call anybody wants. Or this is Fred from the Federal Bureau of Investigation. We'd like to ask you some questions. Also, not how you want to find out that things have gone wrong. So, the PKI infrastructure that backs up code signing itself does have the means to report compromised certificates, right? So if like, oh, something's happened, I can report that to my certificate issuer and say, hey, this has been compromised. That information can go out via what's called a certificate revocation list that basically provides you with data on certificates that may have been compromised, right? So as in many security things, when something does go wrong, the faster you can respond to it and the more you can limit your exposure because of it, the better, right? So, ironically, I think that the biggest issue we see with certificates and doing code signing is people just understanding what certificates they have and when they expire, and how long they're good for, who has used them. You get companies that may have acquired other companies, and it can be a really kind of confusing picture. And that's we're trying to at least either centralize it from a technology perspective, or at least from a logical perspective, so that you have an organization or an entity in the company that's responsible for knowing what certificates are being used for what purpose. And if there is something that's going wrong, or they suspect something might have happened, can know what to do, know how to take action.
yeah. And speaking of, with the organizations you've worked with, does anyone do fire drills, incident response before a real incident has happened?
Yeah, so I can tell you from past employers that we definitely have practiced that a lot more after the breach, because you kind of got the exposure of what it was like to go through one. Now, we were pretty lucky because we had plans in place already. We had an incident response center internally that we could report the problem to. They were able to have forensic data almost immediately to tell them what was going on. We could understand effectively what had been compromised, and because this was at RSA and this is public knowledge, so we don't have to edit this out. But they because they had the capability to be able to look at all this stuff, it enabled them to understand exactly what was compromised. Probably one of the biggest challenges for an enterprise could be, hey, we've had attackers, we discovered some attackers in our network. They've been here for 6 months. We have no idea what they've gotten, right? Because then at that point, you're like, you could assume everything's been compromised, and you have no way to know, or either to refute that or to confirm it. And that obviously makes your incident response job a whole lot bigger, because the fire is everywhere, right? It's not, here's my fire, let me go fight it. It's everything. So but we do see a lot of companies now trying to go through, much like they've done in the past with things like disaster recovery drills, right? A lot of big organizations do those every 6 months or every year. Hey, we're going to fail over this data center tonight, right? Because we have to practice and make sure that everything's working. Same now is true with a lot of security incident response of, okay, what happens if we suddenly find out this system's been compromised? Go, well, what do you do? And that does save a lot of panic and running around in circles when something happens, because not only do you have a document somewhere that tells you what to do, but you've actually done it.
Yeah, I found it really empowering on all of this to do a little bit of threat modeling. That might be new to some folks, but essentially, if you can figure out what does an outside attack look like to us, and then for extra credit, what does an inside attack look like?
Yep.
One of the prominent examples was a subcontractor was phished. And so they didn't even need to compromise the system from the outside. They just compromised his workstation and then moved laterally from there once he was inside. But threat modeling, that's been big. But in all this, has there been a laxness with secrets management, with the protection and, well, I guess the securing of these secrets themselves?
So yeah, from a secrets management perspective, and that's one of the things that's kind of been in vogue the last couple of years is don't have an administrator password, right? Have it be some random piece of of garbage that's untypable, and find a secure place to store that. And then when the time comes when you really need it, we're going to allow you access to that secret to have access to that system. So we do see people kind of going down that path for managing those secrets. A lot of it is just really kind of segmenting that type of knowledge so that it is compartmentalized. So if you do get a compromised contractor, right, it's going to affect a relatively small footprint, right? So back to your threat modeling comment, if you understand what that looks like, okay, well, what would this person have access to? What do they sometimes need access to, but most of the time they don't. And then how do we control that? How do we control the secrets required for that access, or other secrets? What's the password for the service accounts, or what's in the IoT world? Yeah, there's a password that's unique to every module we send out on our lawn mowing robots. So I don't pick a random IoT device, right? Yeah, so that if I need to actually go and service it, I have the ability to, a unique secret for that device, as opposed to one blanket admin password that or one blanket secret that gets posted on the internet within 30 seconds of your first lawnmower going out the door. And, before you know it, people are hacking your lawnmowers left and right because, they haven't protected that. So kind of a far field example, but stuff that we definitely see customers talking about.
Absolutely. Well, Dave, I know you and I covered a lot of detail here. Do you have maybe 3 high-level takeaways in all of this? What should people do? What are 3 things companies should be doing in 2021?
So I think number one is ingrain security in your thinking about your business, right? So easy enough to say, and people have their own security functions that they're supposed to worry about that, but sometimes you need to think about it in sort of the bigger picture. And I think your point about threat modeling is on point for that as well, which is you need to think about what could happen. And I guess the second thing really is don't assume it can't happen to you. I think if anything has been clear over the years in security, it's that organizations that find themselves in a lot of trouble always thought they were okay, right? And I think it is important for them to understand that it's an evolving landscape. Security is not a one shot, like I did this, now I'm good type of a thing. And I think the third thing, which is probably a little more specific to some of the stuff we talked about here, is take a good look at your code signing process and determine if it's appropriate given the maybe size and scope of the development environment within your company. What an impact would look like to you if that was compromised, and your capability to kind of balance ease of use or making it easy for developers versus completely locked down by a security function where developers are having trouble doing their jobs. So those would be my 3. What are your 3, Bill?
Well, first of all, you got to pick a framework. That's been really helpful for me. I recommend it for everyone. Learn your best practices, figure out what you're doing now, where you want to go next. Secure SDL framework like BSIM will go a long way. After that, you got to know your attack surface. There are a lot of attack surface. There's been a lot of attack surface growth in recent years with the complexity of build pipelines and things. So I recommend everybody be monitoring your attack surface. There are great services like one we've been building lately for continuous pen test that help organizations discover all of their external assets, discover what they are, where they are, and what's open on them. Very powerful. I mean, almost every example of a breach has been, hey, someone got in and then compromised the supply chain.
Yep.
It all starts with the attack surface. And the last one is to get serious about secrets management. If someone's compromised your systems, then make sure you have good segmentation and protection of those secrets. No more plain text on the file system. No, thank you. There are a lot of things we could be doing to improve there. Those are my three.
Okay, fair enough. And I think they're all, they're all good points. And, I know the folks listening to the, podcast or the video will, probably have seen some of that in their environment already, but it is important to kind of, keep the vigilance up, right? There's no end of the game, right? It's
right.
I guess maybe when we get to be lucky enough to retire, then we only have to worry about being victimized users instead of security professionals.
Right.
So Bill, you talk about, the attack surface, and, the attack surface really is sort of that laundry list or that inventory of all the potential ways that an environment can be compromised or entered or misused. And I think, we talked a little bit about the importance of really understanding that. Can you give me an example or a situation where that had proven to be important to a customer or a partner?
Absolutely. These companies have moved some of their assets into the cloud, we found that a lot of times it becomes hard to manage what they have. There's an age-old saying, you can't manage what you don't know. And in a lot of cases, the attack surface on a cloud infrastructure can be daunting. So from that standpoint, securing things, you can't even do it if you don't know what you have. So in that way, I've been recommending attack surface monitoring. If you're looking for something to do in 2021, get a handle on your external attack surface. Know what you have, know what's out there, and what's open on it. SynerComm has developed continuous pen test to discover and keep track of everything and show you action items. And that's been a really powerful tool for our customers lately.
Oh, gentlemen, David, Bill, I appreciate your thought leadership today. Expertise and insights, very valuable. To our listeners out there, you are listening to IT Trendsetters by SynerComm. Thank you.